Travelers, no professional mic tonight. I just want to get into it. So the other day, checked out some scientists have discovered a massive ocean beneath the ocean. Now I know some of the flat earther crew out there is going to go nuts with this, but the hidden water is locked in the mineral's crystal structure under immense heat and pressure. And its discovery suggests the Earth's internal water cycle may be much more significant than previously thought. Damn, my fridge is loud. Sorry. Anywho, here's some key details. We're not going to go with the AI because you know things can be hella biased. We're going to try to look for some, I would least like to think, like this. Yeah, see, EDU, stuff like that, not Reddit, .gov websites where stuff has been peer reviewed. So I think the other one was, yeah, the Economic Times is what I first came across it. So we already kind of saw that article. So let's actually go to, Smithsonian. And that's not to say the Smithsonian is not biased either, but I would say they're less likely inclined to do stuff like that. Oh, damn. Guess what the name is right here? Julia Rothschild. Do we really want to read this? Damn, just when I thought I was big up and okay, Smithsonian, you're out. Damn. Brookhaven National Laboratory.gov. Okay, let's check them out. Let's see who's writing on this. This is back in June. Wait, 2014. I thought this shit just came out the other day. This says 2014. So wait, maybe this is old hat, but it's new to me. I don't remember them talking about this, or maybe I did talk about it. What's that effect called? Not the Streisand effect. The thing where people trying to say like the cornucopia wasn't in the fruit of the loom. The Mandela effect. That's what is happening. Maybe I'm having one of those right now. But we ain't gonna be here all night. Let's get into it. New evidence for oceans of water deep in the earth. Water bound in the mantle rock alters our view of the Earth's composition. And, you know, they got a 3DI, 3G, damn, can't even say it, CGI rendering. The study by Steve Jacobson and Brandon Schmatt used seismic waves to find magma generated at the base transition zone 410 miles deep. Editor's note, the following news release was published in the paper Southwestern Journal International Skytron Light. Okay, so it's part of the U.S. Department of Energy. Cool, I guess. Here's the highlights. Scientists have been looking for missing water for decades. Found water could add up to be about the same amount of water as in all of Earth's oceans. Now, this is, mind you, this is fresh water we're talking about right now, at least so far. Findings will aid understanding of how Earth formed. Dehydration of rock. More dehydration of rock? I didn't know rocks get that damn thirsty. Anywho, 400 miles below, U.S. leads to magma generation. And they only talking about what they dug in the United States, mind you. Or wait, hold on, let me see here. Evanston, is that Illinois? No. Oh, illustration. Okay, researchers from Northwestern University and University of New Mexico report evidence for potentially oceans worth of water deep beneath the United States. Okay, so we are talking about the side of the planet. Okay, cool. Though not in the familiar liquid form, the ingredients for water are bound up in rock deep in Earth's mantle. The discovery may represent the planet's largest water reservoir. You know what else holds water? You know what? There's a point to this. If y'all ever seen geodes, sometimes when you crack open geodes, they be capturing water from beneath the surface too. So this is so far very plausible to a layman like me that's just, you know, talking to y'all. Anyways, the presence of liquid water on the surface is what makes our blue planet habitable. We already know that. Northwestern geophysicists Steve and Brandon have located deep pockets of magma 400 miles beneath North America. Discovery suggests water from the Earth's surface is driven to depths by tectonic plates. We know about that already. The finding was published on June 13th in Science. I guess it's just the name of the magazine, just Science. You know, it's kind of, I bet it's just like Nature. You know, like the magazine that just says Nature. And like that's the title, like, but it's a magazine, it's a publication. So geological processes on Earth's surface, such as earthquakes or erupting volcanoes, are an expression of what is going on inside the Earth. So it's burping and farting. The paper he wrote is talking about the whole Earth water cycle, which may help explain the vast amounts of water and liquid on the surface of our habitable planet. There's some diagrams here. Let's go and enlarge, enhance. This is a 9x16 format, so I'm about to pan and scan for y'all. But here's what I assume is under an electron microscope, giving the designation of the ultramicron. I think that's the measurement of what it's called. Someone correct me on that. I know it's magnification for sure. There's that term again. So maybe the epoch times wasn't too far off because they got that ringwoodite that they were talking about yesterday. So that there's some parallels there. Absorption coefficient versus the wave number. So I'm assuming once they shot whatever they did down there to read the waves, it reached up to 4,000 centimeters. That can't be right. Centimeters? Centimeters by -1. Okay, we're using scientific notation here. Hold on. And then you have 200 nanometers, and then the melting, and then perovskite. Okay, let's head back to the article real quick. I do need to know what that UM and then CM -1 is. We'll look that up in a second. Let's see here. Scientists have long speculated that the water is trapped in a rocky layer of the Earth's mantle located between the lower mantle and upper mantle, depths between 250 and 410 miles. That's kind of a good approximate. Usually people just give you round numbers and be happy. It's in between the transition zone, and each region extends across the interior of the United States. I wonder if this is going to talk about how Yellowstone has a giant magma chamber. But maybe I'm jumping ahead here. Hold on. The study combined Jacobson's lab experiment, which includes his study of the mantle underneath the rock under simulated high pressures of 400 miles below the Earth's surface, seismic data from U.S. array across all. Damn, there's 2,000 seismometers across the United States. That explains why I go to USGS first when earthquakes happen. Water stored in mantle rocks, such as containing mineral ringwoodite, there's that name again, is likely to keep the process. There was a video, I wonder if it was just B-roll, but they had a picture of like either a unmanned drone was like leagues below the ocean, and then it showed the actual growth, but then it showed the layer of water on top of water. But that's weird. So it's like, okay, they're probably going to explain. I guess I'm just thinking ahead here because it's like, if you're in water and you find water in water, that means whatever water that's surrounding it is more dense to stay underneath that level. That makes sense, right? Just like how oil is less dense than water and it'll float on top of it. So if you got like heavier water, because its composition is much more dense, it would sink. So you probably wouldn't be able to bring it back up unless you captured it in some kind of like file or something, right? Speaking of which, here we go. The water molecule splits into a hydroxyl radical, or OH. The water is not in a form familiar to us. It's not liquid. Oh, well, I guess I was already thinking ahead. They're explaining it right now. The water is not in a form familiar to us. It is not liquid, ice, or vapor. The fourth form of water is trapped in the molecular structural. So, I'm making it worse. Molecular structural? I'm just tired. It's okay. I just got to work it out too. But it says the fourth form. But is the fourth form actual hydroxyl radical? Splits to form a hydroxyl radical. Huh. I thought I was going to say something like plasma. You know, you got solid, liquid, gas, then plasma. You know, those are the four states of matter that, you know, I'm familiar with. Because liquid, obvious, ice, that's the solid, vapor, gas, plasma. Car horn, if you can hear it. Anyways, whether or not this unique sample is representative of Earth's interior composition is not known. However, of course, you know, you gotta give yourself an exit. But now that we have found evidence for extensive melting beneath North America at same depths corresponding to the dehydration of ringwoodite, which is exactly what has been happening in his experiments. For years, Jacobs has been synthesizing ringwoodite, colored sapphire-like blue, in northwestern lab by reacting the green mineral olivine with a water at high pressure conditions. The Earth's upper mantle is rich in olivine. For y'all don't know, olivine is like this very beautiful dark green looking color. I think I have enough time to jump. This is already a 10-minute video. I don't even know if I can upload this as short. It's probably have to just be a full video at this point. Or I just split it. Let's see, where am I at? Oh yeah, here we go. He found that 1% of the weight of the ringwoodite crystal structure can consist of water. roughly the same amount of water that was found in the sample reported in the Nature paper. The ring would act like a sponge soaking up the water. The study goes on. They did some advanced photon sourcing at the Argonne National Laboratory in the National. Okay, listen to this name, synchrotron. You can't tell that sound like a damn Decepticon, bro. Synchrotron, Megatron. All right. Because the diamond window is transparent, we can look into the high pressure device and watch reactions occur with the conditions of the deep mantle. We use intense beams of X-rays. Now, I wonder if the X-rays are actually is factored into like how these molecules and minerals are reacting. Because, I mean, if you ever got an X-ray before, you put lead over yourself to cover other parts so they don't get bombarded. And then, okay, maybe that's just my esoteric mind just going too far. Electrons and infrared light to study chemical reactions taking place in the diamond cell. But I guess I just have to ask them, like, hey, does X-rays play a factor in what you're able to see? Because if you couldn't see it, right? And just hear me out, folks. Hear me out. If X-rays is the only way you can see it, but we know X-rays move the solid mass in a different way, how do you know you're seeing it in the right way? You know what I'm saying? Let me say that out loud again. Make sure I'm not sounding too freaking stupid here. I'm just saying, if the method of which you are looking at something changes because of the properties of the way you're looking at it, are you looking at it in this original context? Because you can't see these things with the naked eye. You need tools, but the tools have a byproduct of which, if you shoot it with that, it's going to do something to that. It's going to react differently because it's being exposed to something that it's not used to. Or is that hype? I don't know. Is that hype? Okay, I don't know. It might be hype. Let me know in the comments below. It might be hype. I don't know. But that's just me thinking, because it's like, if you bombard something with some radiation, it's going to change its molecular structure at some point. And maybe there is a magnitude at which it does change, but it still sounds like it would do something. We're almost done with the article. Jacobson's finding preceded the same evidence of the partial melt or magma that Schmand detected beneath North America using seismic waves. Because of the deep mantle's direct observation of scientists, seismic waves, sound waves at different speeds to image the interior of the Earth. So it's just like when you got Raleigh waves. I'm just assuming here, I don't know, but when seismologists look at the Raleigh waves, love waves, S waves, and P waves, they all have different wavelengths because they're all doing different things. Anyways, the melting we see appears to be driven by subduction, the downwelling of the mantle material from the surface. Melting, the researchers have detected, called dehydration melting. Okay, now we're on to something here. Rocks in the transition zone hold a lot of water, but the rocks in the top of the lower mantle can hold almost none. Water contained within is forced out as it goes deeper, and then the higher pressure creates silicate perovskite. Oh, that's from the X-ray. That's from the picture earlier. Okay, which cannot absorb water. This causes the rock at the boundary between the transition zone and the lower mantle to partially melt. And then, let's see here. We're at the bottom of it now. So the actual title of the paper is called Dehydration Melting at the Top of the Lower Mantle. So it's the top of the low. So it's the low high. And here I was thinking, I remember in geology, they're talking about that weird muddy clay zone in the mantle that you really can't see, but then they can see it. I don't know, it's just sparking some old conversation up from one of my professors when we were talking about this. I was like, so if no one's really been down there, how the hell do you know what it looks like? But then your instruments don't really show you what it looks like. It's a translucent image. I mean, granted, no pun intended, I didn't mean granted like that, but granted, it's going through solid mass. So you still can't see it. You know what I mean? It's like the only way you see your bones is if you see a cadaver, you rip open your skin and it gets exposed, but you can't see it, but it's there, but you can't see it. So I'm wondering if it's the same thing, because I'm just recalling what Homeboy said in class. He's like, it's like this putty, kind of like mud material that's in between. Maybe he didn't know what the hell he was talking about either. That might be true too. Now I think about it. But let me know what y'all think. This is a 15-minute long video. It's probably too long for a short. So the first part of it's probably gonna cut off at the first 6 seconds, and then if y'all are really interested, you have to watch the rest of the video. But before we dip out, let's go find out what those measurements meant. So we're gonna open with negative exponent. Okay, a negative component on the centimeter is a shorthand for a reciprocal, meaning you should divide the centimeter unit instead of multiplying it. Mathematics. So here's that. So we got that done. So we had, I think I had 2 more. We wanted to see, oh, it means micrometer. So it's equal to 1,000, wait, 10, yeah, thousandths of a millimeter? Or about, oh fuck, what is that? 10 thousandths of an inch? No, tens, hundreds, thousands, 10 thousandths of an inch. I had to actually physically count that. Jesus. That's tiny. Very tiny. Okay, and the last one was scanning, just scanning. There we go, olivine. That's olivine. Isn't that pretty? Very, very pretty. So yeah, that's olivine. That's what I want to finish off with. Okay, bye.